Here are your solutions to 5-5. These are the example problems. Lesson 5 is the Pythagorean theorem. So we could start off right off the bat by talking a little bit about the Pythagorean theorem. In words, the theorem states that in a right triangle, remember this only applies for right triangles, the sum of the squares of the lengths of the legs. Now keep in mind that the legs are here and here, and the way to automatically always be able to recognize the legs is that they both meet at the right angle here. So these are the legs of the triangle. So the squares of the lengths of the squares of the legs is equal to the square of the length of the hypotenuse. And this is the hypotenuse here. So the green is the hypotenuse and the blue represent the two legs. Now again, to keep this straight, the hypotenuse is always across from the right angle, whereas the two legs are always touching and meeting at the right angle. That's the way to make sure you keep these straight. So the best triangle that I can come up with to use to illustrate this would be the 3-4-5 right triangle. In a 3-4-5 right triangle, first of all, we have a right angle here. I know I didn't draw that leg very straight, but that's really irrelevant for right now. And we have side lengths of 3, 4, and 5. Now this doesn't matter if this is 3 feet, 4 feet, 5 feet, or all of them are in centimeters, or all of them are in inches. It doesn't matter. A 3-4-5 right triangle works like this. We have a squared plus b squared equals c squared. Well, remember, a and b represent the legs, and they always meet right here at the right angle. So 3 and 4 are our legs. 3 squared plus 4 squared must equal 5 squared, according to this, because again, the 5 squared is the hypotenuse, which is the one across from the right angle. So now let's take a look at this. 3 squared, of course, is 9, plus 4 squared is 16, must equal 5 squared, which is 25, and indeed 9 plus 16 is 25. It checks out. And basically that is what the Pythagorean theorem says, that if you have a right triangle, you have two legs that if you square each of their distances, you will end up with the square of the hypotenuse if you add those two together. Now let's take a look at this down below. The Pythagorean theorem describes the relationship between the lengths of the legs, and remember the legs meet at the right triangle, and the hypotenuse, which is across from that right triangle, for any right triangle. Remember, this only works for right triangle. You can use the Pythagorean theorem to find the length of any side of a right triangle when you know the other two sides. It doesn't matter which side you know. If you're given one side, you can calculate the other two sides based on this theorem. So let's take a look at what that would look like. Okay, let's take a look at example number 1. It says, write an equation you could use to find the length of the missing side of each right triangle. Then find the missing length. Round to the nearest tenth if necessary. So remember, we're going to round to the nearest tenth. I'm going to scroll this a little bit so that we can see our full problem here, and then we'll start talking about it. So let's take a look at problem number 1. Remember, Pythagorean theorem states that a squared plus b squared is c squared. And our a and our b are always our legs. They meet at the right angle, so we have a leg of 12 inches and a leg of 9 inches. So we have 12 squared plus 9 squared equals c squared. Well, 12 squared is 144, 9 squared is 81, 144 plus 81 is 225, and that equals c squared. So now here's where you need to remember your algebra rules from earlier. Remember, if we know that a number, I'll write it over here, 225 equals the square of a variable, we can take the square root of that variable squared and the square root of the other side, 225, and we would find out that the square root of c squared, of course, is c, and the square root of 225 is 15. But keep in mind that in these situations, remember when we did this earlier in the year, whenever we have a variable squared, we need to talk about plus or minus 15. But in this case, a negative solution does not make any sense because we can't have a negative side length for a triangle, so we just go with the positive 15. We have a hypotenuse of 15 units. In this case, the units would be inches. So we have a 15-inch hypotenuse. Now we can always check that. We can put the numbers in. We have 12 squared plus 9 squared equals 15 squared. Do the math here, and we do have 225 equals 225. We have a solution that makes sense. Now let's take a look at problem number 2. And this is very important to recognize. In the previous problem, we were given the lengths of the two legs. In this problem, we're giving the length of one leg and a hypotenuse. That's very different. In fact, let's back up on that and point that out. This is very important. This is a hypotenuse, and we're given a hypotenuse and one leg. So in this case, we have to make sure we put the numbers in the proper spot in the equation. And what I mean by that is this. We have a squared plus b squared equals c squared. Well, we have an a right here. We could put it in for a or b. It doesn't matter. A leg is a leg. So we put it in for a. It's 8 squared plus b squared, or one of the legs. It could be a or b. It doesn't really matter. But that has to equal the c squared, which is the 24 squared here. That's the key. You cannot say 8 squared plus 24 squared equals c squared in this case. We already know c. That's really important you understand that. So now we end up with this math right here. And we recognize that we need to subtract the 64 here, which we do right here, and we do it on the other side. Now I'm going to write it over here. We have b squared equals 576. And in order to figure out what b is, we have to take the square root of b squared and then the square root of 576. Remember, that's refresher from earlier in the year. We therefore have b equals 22.6 because we're going to round to the nearest tenth. Remember, we're rounding all of these problems. We're going to round to the nearest tenth. Since we were given it in meters, our answer is in meters. We have a side length of for one of the legs. The other leg, other than the 8-meter leg, is going to be 22.6 meters. Remember, the hypotenuse is always the longest side. That's very important to recognize. Please press pause and do letters A, B, and C. And I'll put a reminder here. Remember, you have to notice whether you're looking for the hypotenuse, a C, or in this case B, which is one of the legs, or in this case A, which is one of the legs. Make sure you're using the proper formula. Now let's look at this important point here. This is the converse of the Pythagorean theorem. And what that means is the Pythagorean theorem says as long as we have a right triangle, then the one leg squared plus the other leg squared has to equal the hypotenuse squared. In this case, we're saying that if the sides of a triangle have lengths A, B, and C units such that a squared plus b squared equals c squared, then the triangle is a right triangle. In other words, if we don't know if it's a right triangle, but let's look at that same triangle we had before, the 3, 4, 5 triangle. If we don't know if it's a right triangle, we can square this side, which would be 9, square this side, which would be 16, square this side length, which would be 25, and if 9 plus 16 equals 25, then we can say, aha, we know that indeed we have a right triangle. We can put the right triangle symbol on it. That's what this is saying. It's the reverse, the converse, the reverse of the Pythagorean theorem. Please make sure you have this in your notes. So how do we use the converse? Let's take a look at it here. The measure of three sides of a triangle are 5, 12, and 13 inches. Well, immediately we can say that C has to be the 13 because it's the longest, and the hypotenuse of a triangle always has to be the longest. So we can say that equals 13 squared because that's the c squared. So a squared and b squared could be the other two in any order. So we would have to say 5 squared plus 12 squared. Does that equal 13 squared? Well, 5 squared is 25 plus 13 squared is 144. And we can take a look at that, and we could say that this plus this is 9, 4 plus 2 is 6, and we're at 169, and then 13 squared, aha, that is indeed 169. And therefore we can say, because this equals this, we can say, yes, this is a right triangle. So to refresh here, what you're doing with these, when you're given all three side lengths, you're taking the two shorter legs, squaring them, and adding that number, those two numbers, and then taking the largest number, squaring it, and if your sum of the two smaller squares equals the larger square, you have a right triangle. Please press pause and do letters D and E.